Hi guys, I welcome you all to my channel CSNet Lectures. So in this session we are going to discuss about a problem on queue data structure which is having a combination of queue as well as stack. So the last classes and all we discussed about different types of stack operations and queue data structures, algorithm and so on. So in this session we are going to see a very important problematic pattern of combination of queue and stack. So shall we proceed with the problem discussion? Right. So now this is a problem being written. So first friends, you must have to understand what is a problem and then we can go for solving it. Okay. So now I am going to read the problem so you can also follow along with me. Right. So the 5 items A, B, C, D and E are pushed into a stack. So we are going to create a stack. So in that stack we are going to push 5 elements. So that is being given as a first statement. So one after another starting from A. So from A we are going to insert 5 elements in sequence, that is A, B, C, D and E. Right. So now the elements are being pushed. Next step is the stack is popped 4 times. Okay, so the stack is being popped 4 times and each element is inserted into a queue. So now you see we are using a queue data structure for inserting the deleted elements that is being present in the stack. Right? Then the 2 elements are deleted from the queue. Okay, so the next step after inserting the elements in the queue is we are deleting only 2 elements from the queue. Then once again we are pushing back onto the stack. So the 2 items which are being deleted from the queue are once again pushed back onto the stack. So this is the next step. So now one item is popped from the stack. Okay, so the final the final question is, what is the popped item? So this is the problem which is being given. So now we are going to start solving it by taking each and every statement into consideration. Okay, first I will just give you a brief meaning of what is a stack and what is a queue. So suppose if you don't have any idea, you just watch all the previous videos that I have been given in the description and then you can come to this problem solving, friends. Right. So now what is a queue? So queue is nothing but we are going to insert the element in this order. Okay, as a queue we are going to insert the elements like this one by one. Okay, so what is a stack? So stack is nothing but we are going to insert the elements like this, that is from bottom to top. Okay, so queue we are inserting element in the sidewise and stack we are going to insert the element from bottom to top. So like this we are going to solve it. So in queue data structure we are going to use 2 pointers, that is front and rear. I think so you will be able to remember, right? So what is a stack data structure? So in the stack data structure we are going to use only one pointer which is nothing but top, right? So in queue we are using first in first out method and in stack we are using last in first out method, right? So I have just given you a very brief description. Suppose we cannot understand, I request you to watch all my previous videos and then you just come for solving it. Right friends? So shall we go for solving it? So friends, I have drawn a stack data structure. So in this stack data structure, I am going to insert the elements in this sequence. So what is the first element given? So first element is A, right? Then the second element is B. Then third element is C, D and E. So in this order we are inserting. So we are using a top pointer, isn't it? We are going to delete the element present in the topmost position and if you want we can insert the elements also in the top location, right? So now what is the next statement given? So now we have inserted all the elements starting from A. So now the stack is popped 4 times. So now I am going to start removing the items 4 times from the stack. Okay, so now shall I remove? Okay, so now what is the first element? So the first element removed is E, isn't it? So now the second element is D because this is the last element that is being pointed by the topmost element. So D is removed. Then the next element is C. So C is removed and then B is also removed. Right friends? So now the top pointer is spotting here. So this is my top pointer. Right? Up to now are you all clear? So I have popped 4 times and these are the respective elements. So see, first element is E, D, C and B. So this is first, second, third and fourth. So like this I have deleted the elements from the stack. Okay, so now what is being given? So read from here. So each element is inserted in a queue. So that is after removing the 4 elements from the stack, we are going to insert each and every element inside the queue. So shall I draw a queue data structure? So this is my queue data structure. Okay, I have drawn a queue data structure. So now let me insert. So what was the first element removed? So E was the first element. Okay, so before that I am going to draw 2 pointers. So front and we will be using rear pointer. Okay. So now if you see front and rear. So initially this queue data structure is empty. So there are no elements present inside the queue. So as a result, the front pointer and rear pointer is going to point to the first location. So isn't it? So now actually based on the condition, the pointers will be away from the queue data structure. As the first element is going to come, F value and R value will be incremented to 0 from -1 and we are going to start inserting. So all these things I have discussed in my previous videos, friends. Okay. If you have any doubt, you can go and watch it. Okay. So now the pointer has been arrived as E is the first element which I want to insert it inside my queue data structure. So let me insert. So E is inserted, right? So now I want to increment my rear pointer because the next item is D. So D has to be inserted. So insert D here. Now this is my rear pointer. So once again D is added. So now C is to be inserted. So increment the rear pointer and insert C, right? So now C is also inserted. So the last element is B. So now you insert B by incrementing the rear pointer. So now the front pointer is here and the rear pointer is here. So after this I have completed. Now what is the next statement given? Then the 2 elements are deleted from the queue. Okay, so the 2 elements are deleted from the queue data structure, right? So this is my queue data structure. So this is my queue and this is my stack. So from queue we are going to delete the elements. Okay, so from where I will be deleting the elements from the queue? The elements pointing to the front pointer, isn't it? So the elements pointing to the front pointer. Okay, so that I am going to delete it. So after deleting, where I must have to insert? So the elements are deleted and I am going to push it into the stack. Okay, so shall I draw once again a stack data structure? Okay, so I will draw a stack data structure. Okay, so already if you see A is present, isn't it? So let me add A. See friends, this is old element that is being present, so that I must have to include it. Okay, after that I must have to insert. So now what is the first element? See, we are going to delete it from here. So E is the first element. So I am deleting it. Okay, E is deleted. So this is my first element. Okay, so now the front pointer will be pointing to this location. So D. Okay, so D is also deleted. Okay friends, so D is also deleted. So now currently the front pointer is pointing to C. Friends, are you all clear up to this? Right. So now D and E are being deleted from the queue and we are going to pushing it back into the stack. So what was the first element removed from the queue? E was the first element, isn't it? So add. So E is the first element and D is the second element. So add. So E is added. Okay. So now D is also added. D is also added. So I am removing it. So now stack at current position we are having A, E and D. So D is the topmost element of the stack now. Okay friends, are you all clear? So up to this we have completed. So now one item is popped from the stack. Okay, so now one item is popped from the stack. Okay, so what is that element? At that I must have to find it. So now the last step is one item is popped from the stack. So this is my current position of stack, that is representation of stack. So now the topmost element is D, isn't it? So the topmost element is D. They are telling that we are going to remove this, remove that. So D is removed. Now top will be pointing here, isn't it? Right? So this is my last statement that I have finished executing. Okay. So now what is the popped item? Now can you tell me what is the popped item at last from the stack? So it is nothing but D. Isn't it friends? So now the answer will be D. Okay friends, are you all clear? So this is the way we must have to solve these types of questions. Okay, so suppose if you have any doubt, right from the beginning, you please see all the explanations that I have given for solving these type of problem. Suppose if you have any doubt in spite of once again watching this video, you please tell me in the comment section. I am there for solving it to you. Okay friends? So friends, now I am going to tell you what is a disadvantage of Q. Okay, so if you see, this is a Q data structure, isn't it? So this is a Q data structure. So now if you see in the front position, it is going to remain empty. You know why? Because the front pointer is pointing to this location and the rear pointer is pointing to this location. So rear pointer, that is with the help of rear pointer, I can be able to insert elements only in this order. Okay, so I cannot able to insert any elements here because there are no pointers here, isn't it? So there are no pointers here. So I cannot able to perform any insertion, right? So now after deleting all these elements, okay, so after deleting all these elements, or for example only one element is present, it will be B. So if you see, front pointer will be here. So all these spaces are going to be empty permanently. Okay, so we cannot able to insert any elements. Okay, so because of this what will happen? The memory space is going to get wasted. Isn't it? Right? Can you understand? So what we are going to do? Can you guess? So for this purpose, that is in order to overcome this problem, we are going to use another type of data structure. It is nothing but circular queue. So by using circular queue, we are going to remove or overcome the limitations of using even these empty spaces successively, okay, for inserting the elements. So the meaning is we are going to use this front pointer once again to point to this location for inserting the empty spaces also, or for using the spaces for inserting the elements, that is not wasting the memory spaces, right? So we are going to use circular queue. So the circular queue data structure is implemented mainly for overcoming the successive empty spaces which are being created by the queue data structure. Okay, so in the next class we are going to discuss what is a circular queue and what is a double-ended queue, right? So after finishing this, we are going to see the time complexity of stack and queue data structure, friends, right? So I think so this session will be really very helpful for you. Okay friends, bye and thank you.